right, so today we're in section 4.2, greatest common factor. A factor, okay, does anybody remember what a factor is from section 4.1? What is a factor? John and Deb? Okay, you multiply them to get to a product, or it's evenly divisible by a number. So when we talk about factors of 10, what are our factors of 10? 1, 2, 5, 10. Okay, all numbers that are evenly divisible by 10. Those are factors. So in example 1, they want us to find the greatest common factor in this choir group example. It says the director wants to divide the choir into smaller groups. The choir has 24 sopranos, 60 altos, and 36 tenors. Each group will have the same number of each type of voice. What is the greatest number of groups that can be formed, and how many of each part will be in the group? So there's two ways that we can find this answer. In this example, we're going to do method 1, which is by listing the factors of each number. Not the prime factors, but the factors of each number. Okay, listing the factors of each number. You don't have to write any of this down. All right, now let's break down our three numbers, 24, 60, and 36. Okay, now let's say our factors of 24 together, starting with 1. It's going to be 1, 2, 3, 4, 6, 8, 12, 24. Now there's a way that I can check to make sure I haven't missed one. I can start with my outside numbers and multiply them. Is 1 times 4 24? Is 2 times 12 24? Is 3 times 8 24? And is 4 times 6 24? So since they all equal 24, I know that I've counted all of my factors. I want you to do the same thing for 60 and 36. All right, so let's fill them in. Say them with me on 60. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Then for 36, 1, 2, 3, 4, 6, 9, 12, 18, and 36. So now I'm going to go through, starting with the largest numbers. Well, I definitely know that 60 is not it because that's bigger than the other two. And I keep going down until what do I see to be my GCF? What is the largest factor that's in all three numbers? 12. So my GCF is 12. Well, now let's go back to the question that it was asking us. How many groups can there be? How many groups? 12 groups. So how many sopranos would be in each group? If there's 24 sopranos in 12 groups, how many sopranos in each group? 2. How did I find that? I divided the number of groups by the number of sopranos. I want you on your papers to tell me how many altos will be in each group and how many tenors will be in each group. All right, write it on your paper. All right, how many altos? 5. 60 divided by 12 is 5. And how many tenors in each group? 3. Okay, so I simply divided the GCF by the number in each group. All right, so that's it for example 1. I want to do a quick checkpoint. I want you to find, I'll give you about 5 minutes. I want you to find the GCF by listing the factors of both of these numbers, 12 and 30, and 16, 32, and 40. Find the GCF by listing the factors. All right, guys, so checking our problem. We're going to list out the factors. And now what is the largest factor between 12 and 30? 6. GCF is 6. Then we're going to list our factors for each of these three numbers. And what's the largest that goes into them? 8. Very good. 8 is my largest factor, so 8 is my GCF. All right, any questions? Any questions? You absolutely can use this method when they're very small numbers. This method can be quite useful and honestly be the fastest. A lot of times you might even be able to do it in your head, all right, when it's small numbers like this. However, this method is not practical when when we're finding GCF of really large numbers, like let's say 240 and 360. Well, it's not practical to list factors for numbers that big. So there's another method, prime factorization, that we're about to learn. Before we talk about that method, I want to tell you or teach you just for a second what it means for numbers to be relatively prime. That means that when I look at their common factors, they have no other common factor except the factor 1. Okay? There's no other common factor except the number 1. I call these numbers relatively prime. So just in your notes, real quick, 2 numbers are relatively prime when they have no other common factors except 1. All right, so I have 2 choices here on this example. It says to do the factorization. It says identify whether or not these numbers are relatively prime. Well, the first thing I could do is I could just list the factors of 24 and 45. I could just list them all out just like I just did in example 1 and then see if there's any common factors there. Or I could do the prime factorization. I tend to prefer prime factorization. However, you can do either method. So if you were to do prime factorization of 24, okay, 24 and 45, again, there's multiple ways to do this, but I prefer upside down division. You must always divide by a prime number. To me, that's just quick. You know, it doesn't take long. Once I have the prime factorization done, 24 and 45, I'm going to list my prime factors, 2 times 2 times 2 times 3, and 3 times 3 times 5. All right, so prime factorization, I've got it done. And now I'm looking for factors that both numbers have in common. Do you see any? I see a group of 3s. Okay? See a group of 3s here? So my GCF is 3, so it's not relatively prime. Okay? Basically, what that means is it had a common factor. Okay? Now, if there was no other common factors, my GCF would be 1, and then, yes, the numbers would be relatively prime. So I want you to do the prime factorization of 35 and 54. If there's a common factor, circle it. If there's not, the GCF is 1, and the numbers are relatively prime. Okay, so 35 and 54. I'm going to just real quick do the prime factorization. Okay, 2, 27, 3, 9, 3, and 3. Okay, really, without even listing out my prime numbers, look at your prime factorizations. Are there any numbers in common? No. No, there's not. So I say GCF is 1. And yes, they are relatively prime. You mind if I abbreviate? That's kind of a mouthful, okay? So RP means relatively prime. That would be fine. What now?
Are we allowed to do that in our homework?
You are absolutely allowed to do that in your homework. Okay? Now, let's make these numbers a little bit harder, okay? Because on your quiz and test, this is more than likely what you're going to be looking at. Finding the GCF using prime factorization. Now with 90 and 126, it's not so cut and dry. Okay, as far as I can't just list out my factors, I'd be listing a lot of numbers to get all my factors of 126. So I want to do the prime factorization, okay, prime factorization of both of these numbers and then list my prime factors. Okay, so 2, 45, 3, 15, 3 and 5, 2, 63, 3, 21, 3 and 7. Do y'all agree? All right, so 90 and 126. 2 times 3 times 3 times 5. And 2 times 3 times 3 times 7. Right? Okay, so now I'm going to circle my common factors. Now, if I'm listing factors, guys, I need you to mentally separate these two methods. If I'm listing all of the factors I just pick the biggest one. But if I'm doing it prime factorization, I need to group my common factors, 2, 3, and 3. And for each common factor, I write it one time in my GCF, 2 times 3 times 3, which gives me my GCF of 18. Okay, so that's how I find GCF. All right, now you do this one. Now, for GCF of 3 numbers, we're going to do the prime factorization. The factor has to be in all 3 numbers. Okay, so go ahead and get started on the prime factorization, of all 3 of these numbers. Give you about 5 minutes. All right, guys, lots of 2s. 32. 1, 2, 3, 4, 5. 80. 1, 2, 3, 4, and a 5. And 128. 7 2s. 2, 3, 4, 5, 6, 7. Group your 2s. 1, 2, 3, 4. Can I have another group? No, because there's not another 2 in 80. So over here in my GCF, I multiply each 2 one time. 2 times 2 times 2 times 2. And what's my GCF? 16. All right. Last but not least. Okay, in example 3 now. I'm dealing with monomials. I know that I can factor a monomial. Let's take 10x squared y to the third for a minute. I know that I can factor down this monomial into all of its prime factors, okay? Well, the prime factorization for 10 would be 2 times 5. And then for x squared, how many times would I multiply in x? Times x times x times y times y times y. This is what we learned in 4.1, how to factor a monomial. Everybody remember that? So now, in example 3, I'm going to factor 2 monomials and then find the greatest common factor between these 2 monomials. So for 18, xy squared, I need to know what is the prime factorization of 18. Okay, if you're having trouble with it, come over here to the side and just do a quick upside down division. So you would go 2, 9, 3. So that would be, sorry, I probably should have gone out a little farther. But it would be 2 times 3 times 3. You see how we did that? We just did a quick prime factorization off to the side. Times how many x's? 1. Times how many y's? Okay, and then for 28, again, just come off here over to the side for 28. 2, 14, 2, and 7. So now you've got 28 x squared y squared equals 2 times 2 times 7. How many x's? Times x, how many y's? Times y times y. And now I can circle my common factors. Any numbers? 2. Any variables? X. Any y's? How many y's? 2 y's. And now my GCF is 2xy squared. They don't necessarily have to be lined up, but it helps when you're grouping them. Okay, so GCF is 2xy squared. You think you can do the second one over there, 9ab and 12a squared b squared. I don't care how you do the prime factorization. Okay, for 9, that's pretty easy. Okay, for 12, just make sure it's the prime factorization. There's no composite numbers. Go ahead and find the GCF of these 2 terms. All right, so what's the prime factorization of 9? 3 times 3 times a times b. What about 12a squared b squared? 2 times 2 times 3 times A times B times B. Okay, so what's my common number? My 3's and an A and a B. So my GCF, oh sorry, hold on. That was a bad G. GCF is 3AB. On your homework, they get a little harder than that, but that is overall the same concept that you're going to use on your homework. They do get a little tougher, guys, but it's the same concept. Break it down into its prime factorization, numbers and variables, circle the common ones, and then multiply them together. If you understand that, it's everything you need to know for 4.2.